Welcome, everyone. My name is Chris. I'm the CTO and co-founder at Ona. And with me, I have Leo and Laura. Over to you, Leo.
Hello, everybody. I am Leo, and I also work at Una. Guess what? Where I daily mess up with kernel level guardrails, or as we may call it, agent security. I hand it over to Laura, my dear friend Laura.
Hey, I'm Lore. I work with those two that just presented themselves. Same things. Been working on Falco with Leo, been writing a book on VPF observability. Many things around security that I cannot even list. Let's go.
Beautiful. So, in great company, a lot of deep knowledge here around security and how to make running stuff more secure. Now, you both have been doing this for a long time, and you've passed well through the container era. Now we're talking about agents. Tell me, what's different between securing containers or workloads in containers and securing agents?
Should I go, Laura? Or you
Yes,
go?
please.
I just want to say a sentence. The sentence is very short. It may sound a bit punchy, but I think it's the reality. And containers didn't reason, didn't mess around, didn't have autonomy, didn't have transient intents. You know, AI agents have that, and that changes the landscape completely. I don't know if for good or for bad, but it does.
So when I run an agent now somewhere in the background, as compared to running production code somewhere in the background, what is it that I want to think about? How do I need to reason differently compared to the sort of more traditional application security I'm used to?
Well, we have all been pulling from NPN. We've all been pulling untrusted images. Like most of our, most of us, we just like started thinking about it couple of weeks ago, and that we don't pull random stuff from the internet and run it on our machines. And now there is this problem that containers and packages and the programs that we pull are also not dumb. So this is what changed. We just got used to pull random stuff from the internet and run it. And now that random stuff we pull is not dumb.
Can you make that more concrete? Like what's a consequence of that?
Think about the fact that you just have things running on your machine and they can take advantage of exploits, run any scan without being blocked by someone giving them an instruction from the outside. They don't even need to be instructed. They can just go straight to the point and do the things that they have been missioned for. This like reduces a lot, increases the attack surface, but also reduces a lot both the need for the attackers or the people trying to exploit this to control, which is what was also blocking them. They like might set up scripts to do things and only have a limited set of findings they could make. Like think about it, like we've all seen in the logs, scan for the WordPress admin, scan for MySQL credentials, these kind of things. Now they can just like automate the exploit fully, start doing things and reason about this specific system. So even if your application is proprietary, even if you don't run a very famous piece of software that has a vulnerability, they can find it in your code base, in your software, in real time. And also, they can automate the attack. So they can just start attacking more targets from the outside in an automated way, which is 1,000x more powerful than before. It's actually very exciting, not just more powerful. But sometimes I'm sad that I'm not on the attacking side.
Help me understand that. So I'm running Claude on my local machine. What should I be worried about? You say there's now, like, as compared to say running a Docker container before, like what is the thing that's now happening that before didn't happen?
And let's say that you open your beautiful coding agent, whether it's cloud or another, and you task it with an intent. and you gave it a task. Today you have to do this thing. Please look at these files. Blah blah blah. Write this kind of code. Use this architecture. You beautiful prompt, whatever, and then you leave it there. You may have set up sandboxes or things like that that ask you for to be in the loop and ask you for approval of stuff. But it turns out that the level of attention, I mean, we are in the attention era, right? And these things require our attention on things that most of the time in daily usage, people doesn't put the correct level of attention to. Normally, imagine when you have an autonomous a crazy animal, let's call it like that jumps around your computer or your machine or whatever you're running that craziness, and performs whatever command is, whatever it takes to reach the goal that you originally gave it. This means that while doing so, it can also have transient intents, do other stuff that you didn't want it to do, but it does. And it may ask you for confirmation. It may ask you for 500 times confirmation, and then you're code in approval fatigue, and you do a mistake. You say yes, and they disable its own sandbox. I did a demo months ago about that, and when that happens, you screwed. Sorry for the French. You're a bit screwed because, for example, it may run npx, which pulls the hacked actions from the npm registry on your local machine and dumps all of your AWS keys to a command and control God knows where. And then, well, then at that point, what's left is you can only do forensics, and post-mortem most of the time. So we're trying to build the guardrails at the level that's out of reach from the agent, that even when the agent goes crazy, we can still impede it, forbid it to do stuff. That's why, for example, why we're working on things like Veto and Data Voladora. But I hope I answered your question, Chris.
Yeah, before we jump there, I want to double click on sandboxes. So, Codex and Claude, they all come with sandboxes out of the box. What's wrong with them? Like, don't they solve this problem? And if so, why not?
Yeah, that's a very good question. First of all, I don't personally think that is wise to run any coding agent, any AI locally on your machine. I don't do it. I stopped installing any tool because now it's too scary for me. My personal threat model doesn't allow me to do that. So start with this assumption. Even if we have a sandbox, most of the times it's a bubble wrap sandbox or something that I don't want to get into the technical details now, but I don't think it's enough. Even a micro VM, for me, it's not enough. It's still in my machine. The amount of exploits, the amount of possible things that can be done now with AI is not enough for me to be sure that that agent prompted correctly or with a 0 day that someone might have does not escape it. Okay, so this is super important. In your computer, you have everything that is valuable to you: bank account, your family pictures, whatever. If it's a work laptop, you have your company PI, you have everything. You are one step away from leaking not just your AWS key. Who cares if they spend thousands on AWS? Think about your most important information. A video of you while you work on your laptop for a day, like that, or while you brainstorm with your wife about something that you want to do. Whatever, like it's in your house, right? So that's the level of threat that I'm thinking about, and I cannot allow that to be in. And I hope that people don't get this lightly, no? But we know has been like this, like, because people just install things on their laptop without thinking. Now it's not the moment, even more than in the past, in my opinion.
So with agents, one thing that's very interesting is that before we had a whole class, like the highest class of CVE is remote code execution. And with agents, text has become executable code. So an agent visiting a website is essentially a form of remote code execution, except we don't treat it as such.
Yeah.
What
True.
currently exists in the ecosystem to prevent arbitrary remote code execution on my laptop? Leo, maybe you take this first.
What currently exists? First, I want to say something about sandboxes, and I totally agree with what Laura was saying. I will just add that, I've heard people talking about sandboxes like it's this panacea that solves all the problem in the last months. But I think the first thing that must be said about sandboxes is trying to define what sandbox is, because I've seen people calling sandboxes also containers, and honestly, that made me shivers. We have seen the copy fail exploit that was in the wild since 10 years.
Just in
So
time.
that thing, together with what Laura was saying, and with the fact that you also were saying that text is executable code and that can go rag and do other things that you didn't write, you didn't ask to do, but it does, because in its own reasoning is a way to get there faster, a way to get to the result faster in its own thinking. For example, the npx stuff, you may have a sandbox that says, no, don't run npx. Npx is in the command analysis. Guess what? If the agent thinks that it needs to run npx to run a script, it's gonna, the moment it gets blocked, it's gonna move the npx binary, copy it to another directory, symlink it, even load scripts with dynamic linking. I don't want to go now too deep and things like it just will make it work, just will find a way to make it work. I think that the only way that we have to create some level, some boundaries to those things is to actually create jails. Jails is not, can be misunderstood, but let's say I can create boundaries, kernel level, that the agent cannot have access to physically, okay? Cannot program, cannot change, cannot tamper with, okay? If you have a command list which is a JSON file, it's gonna tamper it. If you have a command list which is in kernel, and it's way more difficult, it can. I don't want to say it will not do it. I just say it's more difficult. So it's about, increasing the likelihood that it's more difficult for the agent to bypass stuff. It's all about likelihoods and statistics nowadays.
I want to go there in just a moment. I think what you're touching on is very, very interesting. How can we sort of extend the time it takes for an agent to do the wrong thing? Now, as long as this runs in front of you, and we've all seen folks with like 10 terminals open running Codex or Claude or what have you. There is already a form of, you called it a vigilance problem, or like the ability to observe these processes. The moment we talk about background agents, by their very design, they are no longer subject to direct supervision. It's the whole point, right? In order to scale out the production process, if human attention is required in the process, we don't meaningfully scale. Now, if we remove direct human oversight, what problems get amplified? We touched on some, but what are the things that we really want to think about? Tenacity is one thing you brought up. So the agent sort of hammering away, trying to find a way to do whatever it is you told it. What other sort of threat vectors and scenarios come up that aren't maybe immediately obvious? Laura, do you want to take this one?
Yeah, that one keeps me up at night. The main issue that I see is not okay. Imagine that let's rewind a little bit because I think it's helpful. When you look at your terminals, or you have like a Tmax or you have ONA or whatever, like you have that is there and you can look at it, you kind of feel already a false sense of security. Now, because you look at it, you think you know what it's happening, right? And then like you can add whatever tool you can add, like you can add the packet inspection. You can like get all your commands printed to a CM, like, and see them and have something analyze them, and so on. You can do the same with background agents, right? You can just like get everything into CrowdStrike or whatever you want to send them, and you think you're gonna see them, which for the obvious thing is true. We had this experience with Falco as well. Like when you look at the ball being thrown, you see the ball being thrown. You know that the ball shouldn't be thrown there, right? But the problem is when you throw the ball right, throw the ball left, it's allowed, throw the ball here, throw the ball there, and all of a sudden, you find yourself in a situation where it's the incremental set of things that happened that make the exploit happen, that make the attack vector succeed, right? And attackers are very aware of this. They don't, when you see a CV, when you see an exploit, it's rarely useful on its own, right? For example, the copy fail one, you could exit, you could privilege escalate a container from a user to the root machine, you could privilege escalate a process, etc., yes. But you first need to get a shell. You need another exploit to get a shell. You need another 0 day or another CV to get a shell. It's stacked. It's only a matter of time that attacks get executed against background agents running in months of them running and being prompt injected, maybe from different websites, maybe from different sources. Right now, actors are planting on the internet, on the model themselves, these kind of attacks. And that's what we have to defend against now. Now, I think it's the best moment to run background agents more lightly because it's still new and those things are not already planted very well. So now it's a moment where like it's rare to get attacked like that. But in 6 months, when everything is very well placed, and the attackers are gonna have like done all the trial and error now because they don't control the systems, but they're gonna start seeing the signal. So this honeypot has been triggered. This has been triggered. They're gonna start seeing what works, what not. It's now too early to see that, but it will happen. Promise, it will happen.
So that's a quite sobering outlook. On one hand, the optimistic part is today we can still run these things reasonably unencumbered, but there's an expiry date on that. Leo, looking at this scenario that we're moving towards, what can we do? What are techniques that we can put in place today? What are maybe also some of the things that you're working on that or the two of you are working on that would help us defend against that? How should someone putting background agents into production think about here are the capabilities that I need in the future in order to make this a secure thing?
Thanks for asking, because that's very much needed. I mean, I guess nobody wants to go back, be vigilant and being in the loop with the agent. Just to connect back to what you told before, and we all would want to to have background agents running in parallel for the next 24 hours doing stuff that we don't want to do anymore because we want to go at the beach. I don't know, but I mean, I personally would. But so how do we solve this problem? I have ideas. We have ideas. Me and Laura are working on that, as you probably know, given you're my CTO. But these ideas usually move in four directions, four angles or layers, if we want to call them. So there is our idea is there is a first layer, which is let's call it, or in this stack of ideas, the observe layer. Okay, always on, kernel audit, tamper evident, scoped per environment, where each environment itself its own boundary. So there is another layer and direction here, if you wanna. And this is, let's call it, this is part of the foundation. And this layer, this observe part of the stack, throws out data from the kernel, where the truth is, the only truth actually, where you actually going to see what's happening, not what the AI is telling you that it's doing, not what the text is it's telling you, what actually happening under the hoods, in the interface with the physics, with the reality. Then there is another layer which uses in my opinion, the data coming from the truth, from the kernel, to guide in a loop the environment where these background autonomous agents live. The same way that they loop, we need an intelligence, a secure that implements security in a smart way, in an adaptive way, that gets guided and steers itself depending on what's happening lively or runtime on the computer. So runtime security is not anymore just about catching what happens, the single event. It's also adaptive runtime security. This is what I'm trying to say. And by getting those data out from the kernel and guiding the posture, the security posture of the environments, you can dynamically, just the same way that background autonomous agents are dynamically in their intent and the things that they do, increase the security posture. And those data coming from the kernel will also spot when hard guardrails implemented at the kernel level with in3 LSMs, with BPF, made to contain or to block the malicious activities, will notice. Let's say that you have an hard guardrail, and for some reason, the AI agent, the background agents, after trying for 24 hours, is able to bypass your containment, kernel level containment background agent. Then this system that I'm describing, that we're thinking about, will observe that happening and will take countermeasures immediately. This is what I think is gonna be the only way forward for having a really autonomous background agents with sleeping at night. I don't want to be like Laura, that doesn't sleep at night. I want to sleep at night.
You pointed two very important constructs here. One is the fact that going forward, security policies are no longer static artifacts where you have, say, allow and deny lists, but you need a more reactive system that can actually understand what's happening and correspondingly act. Now, this probably lives on two sides. One is papers like Camel and the likes, where based on user trusted input, there is the computation of a permissive hull, essentially, like the permissions that the agent is allowed to have. You I don't know, you need to fix this bug, so you're allowed to read linear and you're allowed to make changes to the repo, but you're not allowed to read Notion or something else because you don't have to for this bug. And then there is the reactive part, where based on what's happening in the environment, we react to
Yep.
we update our security posture. Now, that is probably an LLM too. How do you
That
avoid that
could
from
be
getting compromised? How do you avoid how do you harden the security system itself?
that could be an LLM too, not only. That could be an LLM. The thing that I stress about, that could be an LLM that reason and uses deterministic data, not just statistics, to score what's actually happening, what's the intent, what's the declared intent, and what's the real intent. And this is, what actually I think we are going through, and one of the only possible solutions that we have on the plate. And look, I just want to clarify. I'm not saying, that, for example, when it comes to rules, we only going to have dynamic rules. We're probably going to have Falco rules written in YAML, things like that, that cover, the baseline of security, of the security posture. But it was a problem already before having to write YAML rules. We and Laura knows this very well. I guess Laura can tell you stories about the Falco rules. But the, I was pointing, this the dynamicity of the environments, of the reality we live in, to say that we also need system to craft on the fly the 20% of the rules that will cover the 80% most impactful problems that background autonomous agents can create. One of these being, for example, the exfiltration of sensitive data, credential data. I guess Laura has a lot to say on that.
I'm handing over to Laura, and we're coming towards the end of the session. What can I do today? I want to run background agents today. I want to make this secure. What can I do?
That's a very good question. Be paranoid, but allow yourself to experiment. meaning I'm the first one. I go up and down on this. My brain doesn't allow me. If I were listening to my brain, I wouldn't even use AI. Okay, so that is one part of me doesn't want to use it because it's too scary, it's too dangerous. Another part of me analyzes it. Another part of me just goes wild and uses it. And every time I see something strange, I get paranoid. So for now, scoping down as much the credentials that you give, you think about it in this way. You now have a company with 1,000 employees. This is it. What do you do? Just give them your credit card, like call American Express, give them credit card to each one of them, and with unlimited spend, and give all of them access to everything you have, and like give them all of them your WhatsApp account, because just in case, and your Gmail and everything. We will not do that. This is my advice. This is the important thing to do, and allow yourself to experiment. It's very early. I think that the threats are there, but not yet as sophisticated. So it's time to experiment. At ONA, we are not trying to make it perfect, but we acknowledge that while it's easy to prompt inject, it's also easy to counter that, because prompt injection is not deterministic. And so even a small steer in the prompt injected prompt can fix it. So if you protect at layers, so if you protect on the machine where it is happening, if you protect on something that controls what is the code doing, like if you have protection in the code review, if you have protection in the production systems, if you monitor them with another AI, like I know that it's another AI that can be prompt injected, but what are the odds that all of them get prompt injected, and all the security tools that are executing against this at all different layers are all wrong on this? That's a reason why in real companies that are multiple layers of people approving things, when they get to escalate permissions and when they get important, and when something is, let's take when you like have to get an house loan, like you not just go to the bank and like the first employee tells you yes. They go and do checks, they have a checklist, they do different things, no? And then if something is odd, it gets flagged. But maybe that something gets flagged, same situation, gets flagged for Chris, but not for me. Just because there's a little steer, it's the same thing as the real world. We just have to define and make mechanics around those. At ONA, we are trying. If you don't use ONA, try to do it yourself. But always defend in depth. Don't just like think, oh, this is, even if you see a tool that is popular on X, whatever, just like, let me tell you this. If a tool for security comes with NPX, like, no? If you have to do NPX something to secure
And yet,
your...
block execution.
no, it's think about, like, you can stop thinking about your code, you do your harness, but this thing, think about it. Think about it, put layers where you think they're, you follow your instinct on this. Follow your, where do you think it's
That's
important?
great. We're running out of time. That's a great place to end. We need defense in depth. Don't run security tools that come with NPX. And now is the time to experiment. Yeah. Sorry, Leo?
Don't give them all the credentials too.
Yeah, don't give them the credentials. Thank you both so much. Really learned a ton. Enjoyed this conversation. And yeah, enjoy the rest of the summit.
Likewise.
Ciao, ciao.